is going to be, and this is question 9-28, part A, we have the equation y equals 4x squared minus 121. So again, and I'll move back up so we can see our checklist of items to go through. Our first question is the a value negative? So we look at that positive 4x squared, and it is not negative. So we can move on to the second question that we have to ask. Is there a common term that can be factored out of all of the, technically in this case, a binomial, but out of all of the terms? Do 4 and 121 share any common terms that we can divide by and factor out into the front of it? No, it doesn't. So we're going to move on to our third. Does it meet the special case requirements for either difference of squares or to be a perfect square trinomial? In this case, the answer is actually yes. We look at the 4x squared and we tell ourselves, well, 4 is a perfect square. Then we look at our c value, which is 121, and it is also a perfect square. Then we realize that they're separated by a negative sign, again, which is why it's called difference of squares. They're both perfect squares, and they're separated by the difference, or the negative sign. Therefore, we look back up here, difference of squares falls into the factored category, which is why we'll be using the factored form to solve and simplify this quadratic equation. Because this is difference of squares, we would again be able to actually immediately factor it into factored form. We again take the square root of the a value. The square root of 4x squared is 2x, and it goes into the first spot in both parentheses, both factors. The square root of 121 is 11. And because we know that we need to end up with a negative 121, the first one is going to be positive, and the other one is going to be negative. And voila, we have our factored form. Now we can then go on with this. If we need to actually solve for the roots, we would again use the ZPP, zero product property. We got 2x plus 11, set it equal to 0. We got 2x minus 11, set it equal to 0. We're going to get rid of the constant first in both situations, leaving us with 2x equals negative 11 and 2x equals positive 11. Divide by that coefficient of positive 2, and that's how we're going to yield our two separate roots of negative 11 halves or positive 11 halves. And again, one more time, if they asked us to explain what this means in the context of the graph of the parabola, we would say there are two real roots, which means this parabola, and I know it's again positive because it has a positive 4a value, crosses the x-axis twice at two different locations, at both positive 5.5 and negative 5.5. All right, let's move on to part B. Part B tells us the new equation of y equals 2x squared minus 2 minus 3x. Now the very first thing I'm going to do in this equation is I'm going to rewrite this into standard form. Currently it is not in standard form, and that is what this question is trying to kind of like trick me into doing. They want me to not notice that the 3x, or the negative 3x, is in the place of the c value, where the c value should be. So first step is to rewrite into actual standard form. Y equals 2x squared minus 3x minus 2. My next task is to figure out which method I'm going to use. So again, I'm going to ask myself, is there a negative a value? Actually, I'm going to look over here. Is there a negative a value? No. so I don't need to do anything there. Is there a common term that all three share? No, I have a 2, a -3, and a -2. Nothing shared. Is it a special case? No, because 2 and -2 are my A and C values, and neither of them are perfect squares. And they both have to be perfect squares to be a special case. Therefore, my next task is to determine if this is factorable. We do this by using our diamond factor. I'm going to draw my little x. I do my A value times my C value, so I get -4x squared. I put my B value down in the bottom, -3x, and I ask myself, is there any way to multiply to get -4x squared, but add to get -3x? I would probably go over here and make my little list. I have 1 times 4 and 2 times 2. Those are my only options. Therefore, I have a -4x and a +1x, and I can factor this. -4 times +1 gets me a -4 up on the top. -4 plus +1 gets me a -3 down in the bottom. Because this is factorable, I can go ahead and put it into the generic rectangle. I'm going to take my A value over here, 2x squared, take my C value over here, -2, don't forget that negative, and I'm going to take my two factors from the left and right side of my diamond factor, -4x and +1x, and then I'm going to find the commonalities between each of the horizontal and vertical alignments here. -4x and 2x squared share a +2x. -2 and +1x share a +1. 2x squared and 1x share just an x, 1x technically. And then -4x and -2 have a common value of -2. Which is why our final answer would be y equals x minus 2 times the quantity of 2x plus 1. Because this is obviously factorable, we have chosen to use the factored form of the equation. Again, for part B. And again, if we were to solve this, we would use the zero product property, x minus 2 equals 0, and then we'd add 2 to both sides, so we'd get x equals +2. 2x plus 1 equals 0, subtract the 1, and divide by 2. And we get x equals -1/2. Again, we have two final solutions, which means two real roots, which means this parabola crosses the x-axis 2 different times.